Alright, welcome back Year 9 to another video looking at indices. What we're going to look at today is the zero index. So what do I mean by the zero index? Well, exactly how it's written, an index that has a value of 0. So you can see here I've put an example, A representing any number to the power of 0 is what we're concentrating on. This is a very special case with our indices laws, so we need to look at this one in lots of detail just so that we are reminded every time we see this 0 what that actually means. Now, what we're going to do is look at this in terms of a table. So you'll see down here, I'll just zoom down a little bit for us, that's the full table there. We're going to see what happens with our numbers as we progress down from 4 to 3 to 2 to 1 to a 0 index. Let's begin obviously with this one up here, 2 to the power of 4. What does that equal to? Well, obviously it's 2 times 2 times 2 times 2, so you can see that that's 16. If I do the same with 2 to the power of 3, I get 8. 2 squared is 4, we know that one. 2 to the power of 1 is 2. I'm going to do this one here before we get to the 0 index. Now, we can start this way if you like. 5 to the power of 1 is 5. 5 squared is 25. 5 to the power of 3 is obviously 5 times 5 times 5 again. And if we multiply that by 5, we get 625. So getting up into some really big numbers up here. Now, we want to complete the table by following this pattern. So if we follow this pattern down to 5 to the power of 0 or down to 2 to the power of 0, we should actually see what these two equate to, so what they're equal to. Let's have a look and see if we can see a significant pattern. 16 to 8 to 4 to 2. What's happening? Should go from this one to this one to this one. What operation are we doing each time? Yes, we are dividing by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So to complete this pattern down to here, what do you think we should do? We should divide by 2 again. 2 divided by 2 is 1. Let's do it the other way. 625 divided by 5 would give me 125. Follow this again, divide by 5, divide by 5 to get 5, and finally to get 5 to the power of 0, I can do that, follow that same process, and we get 5 over 5, which is 1. So as you can see, despite we're using different numbers here. We're obviously using base 2 in this left column and we're using base 5 in the right column. We've actually got the same result here, haven't we? 2 to the power of 0 is 1. 5 to the power of 0 is also 1. Let's have a look at our rule up the top. I wonder if we can complete it. We have only looked at 2 examples, but I can assure you if we used any other number, this is our final result. This is the 0 index. Any number to the power of 1 to the power of 0, what am I saying? To the power of 0 is 1. Here we go, we'll fix that. Now this does not include the number 0. That's a special case. Okay, so we're not doing 0 to the power of 0. But for any other number, if we raise it to the power of 0, we get 1. Pause here. Let's put this rule here into our summary books. You don't need to copy in that table. That's just a way for me to help show you why a 0 index is equal to 1. I'm going to show you another way as well. Here we go. So this is proving it, or just another way of explaining it. Consider that you've had this problem here, 2 to the power of 4 over 2 to the power of 4. Now, if we simplify that using index laws, as we can see, we've got same base, we've got division happening. So what do? We subtract the indices. So that's what we get. 2 to the power of 4 minus 4, which is 2 to the power of 0. Okay, what about if we were just given this problem? Is there another way we could simplify this? Well, we've got a number here divided by itself, don't we? We could evaluate and have a look at it as its full number, 16 over 16. What is a number divided by itself? It's 1. Can you see here that what I've done is I've actually got two answers for the same problem? My two answers are 2 to the power of 0 and 1. Now mathematically I could write this in a pretty neat way. I can write it like this. If 2 to the power of 0 is equal to this problem here, 2 to the 4 over 2 to the 4, but I know that 2 to the 4 over 2 to the 4 is actually equal to 1, I can make these all equal to each other. And what we get is just like we had in the first slide. A number taken to the power of 0 is equal to 1. Any number. So if you had a huge number, and that was to the power of 0, your answer is still 1. Isn't that interesting? The next one we'll look at, next slide, are some examples. So how are we going to use the 0 index? Let's look at this one firstly. M times n squared, or mn to the power of 2. This whole number, you'll see it's in a bracket, so it means the whole thing is being raised to the power of 0. We're taking this number in the bracket to the power of 0. So, thinking back to what we've just done, what is a number to the power of 0? And that's our answer. That simplified is simply the number 1. Let's look at this next one. This is a little bit different. A to the power of 0 by b squared. A to the power of 0 is 1. That is being multiplied by b squared. Simplifying that is just b squared. Try the next one before I do it. 7 to the power of 0 is 1 plus 2x to the power of 0. Well, x to the power of 0 is 1, so this is the same as saying 2 times 1. 1 plus 2 times 1 is 1 plus 2 is 3. Let's do the next one then. You might like to try it before me again. This number here, 3x, is being raised to the power of 0. Any number to the power of 0 is 1. Minus 4 times y to the power of 0. Now y to the power of 0, that there is equal to 1. So this is saying 4 times 1. 1 minus 4 times 1. Well, that's 1 minus 4. That's negative 3. Finally, this one looks a little trickier, doesn't it? We can do this one perhaps in 2 steps. Now, recall your index laws that we've been working on. What I'm going to do for this first one is make sure I raise every number or pronumeral within the bracket to that power on the outside. We do that by multiplying across, don't we? The same with this one here. Now we do have a 0, so all that's going to mean is when I do this one, it'll be 0 times 3. So, first step, 4 squared, x squared, y to the power of 2 times 2, which is 4. That's multiplying by x to the power of 2 times 3, y to the power of 0 times 3. Okay, next step. Well, I've got 16 here, don't I? 4 squared, 4 times 4. This one here, x squared, I've got another x over here, so same base, it's being multiplied, so I'm going to add the indices. 2 plus 6, 16x to the power of 8 is what I've got so far. And finally, this here is just a 1. So that's just saying 1 times x, isn't it? Another way to look at it is y here, another y there, so same base, add the indices. Well, I've just got 4 plus 0. It's not actually going to have any effect. This is my final answer, 16x to the power of 8, y to the power of 4. Pause here or up here so that you can jot down these examples if you would like them for further reference in your book. Thank you very much for listening again, and see you in class.